welcome to Unit 8, Lesson 4, where we'll learn how to construct a box plot and compare data sets. Before we start making box plots, let's remember the 5-number summary we learned in the last lesson. This is a list of 5 numbers, including the least value, first quartile, median, third quartile, and the greatest value of a given data set. This list is going to be very important when we make our box plots. A box and whisker plot, or box plot for short, is the visual representation of this 5-number summary. Between the minimum value and the first quartile, and the third quartile and the maximum value, are what we call whiskers. And between the first quartile and the median and the third quartile are the 2 boxes of the box and whisker plot. The 5-number summary and this graph splits the data into 4 quarters. This is an important rule to understand called the 25% rule. It says that within each of these 4 parts of the graph lies 25% of the data. Along with dividing the data into 4 equal quarters, we can also tell the shape of a data set using the box plot. If you notice that the whiskers and boxes are all pretty similar sized, then the data has a symmetric shape. If you notice that one of the whiskers is especially long to the right, we would call the shape skewed right. And conversely, if you notice that one of the whiskers was really long to the left, you would call it skewed left. There are other shapes we could deal with, but in this class, we're going to focus on these 3 types of shapes: symmetric, skewed right, and skewed left. Now let's do a problem where we're dealing with the number of runs batted in, abbreviated RBIs, for former baseball player Julio Franco. So each data value, like this 0, is going to represent a number of RBIs he got in a particular season. So one season he got 0, another he got 3, 8, 8, and so on, all the way up to a year where he had 98 RBIs. Conveniently, this data has already been put into numeric order for us, which should make it easier to find this 5-number summary. I'm going to start things off by counting how many numbers there are. And I see that there's 27 data values. Since there's 27 data values, the middle number would be the 14th value, because then there's 13 to the left and 13 to the right. So our median is going to be 44. Our least value here is obviously 0, and our greatest value here is 98. Now remember, the median cuts the data into 2 halves. In this first half, there's 13 numbers, so the middle number would be the 7th number, and that would be our first quartile, 16. And the second half of the data would also have 13 numbers, and the middle number would be the 7th number, which we might need to count to. And we see that that middle number there is 78. And now we have our 5-number summary, which is going to allow us to make our box plot. To construct our box plot, what we're going to do is we're going to take each of these 5 numbers and we're going to plot them above the x-axis. So for example, to plot 0, I'm going to go above 0 on the x-axis and plot a point. Now when I'm using Notability, I like to do a little trick here where I drag a straight line here to make sure that all my points are at the same height. So next I'm going to plot 16, a little bit past halfway between 10 and 20. Then I'm going to plot 44, a little short of halfway from 40 to 50, 78, just short of 80, and 98, just short of 100. I'll get rid of that little guideline, and now I've got my 5 values plotted on the graph. Remember that on the end of each half of the box plot, we have a whisker going from the least value to the first quartile, and another whisker going from the third quartile to the greatest value. Then remember, in the middle we have that box, which requires us to have some lines going vertically through each of these middle dots. And finally, we remember that there's a box in the middle, so I'm going to connect these lines to make that box shape in the middle. And there we have it, we have a box plot. And now we're going to get asked a couple of follow-up questions about our data now that we have this graph constructed. The first question asks, what percentage of the data lies between LV and Q3? Well, LV starts here, and if we work our way towards Q3, which is 78, we see that we've shaded 3 quartiles. Remember that each one of these quartiles contains 25% of the data. So between LV and Q3, we have 75% of the data. 25% plus 25% plus 25%, 75%. So whenever we're asked how much data lies between certain numbers in our 5-number summary, we just need to count up how many quarters that is and add up 25% for each quarter. And lastly here, they ask us about the shape of the graph. When I'm determining the shape, I'm going to compare the 2 whiskers. If I notice that one whisker is especially longer than the other whisker, I'll say that the graph is skewed in that direction. In this case, I think that these whiskers are close enough in size to call this graph symmetric. And a lot of times we'll use the word roughly before symmetric, since it's not perfectly symmetric, but it's closer to symmetric than it is skewed. One of the really nice things about box plots is we can use them to compare two different data sets. We've learned throughout this unit that data can be described using shape, center, and spread. With box plots, we can easily compare the medians of two data sets. To discuss center, we can easily use the different ranges of the box plots to compare spread, and we can continue to use the concepts we've learned about shape to compare the shape of each of the data sets. So in this next example, we're asked to compare the shape, center, and spread of two different bookstores and the prices of their books. First, let's look at the shape. I notice that both Bookstore B and Bookstore A have much longer right whiskers than left whiskers. So I can say that both data sets are skewed right. And that's all I need to do to compare their shape. I just have to describe the shape of each individual data set. Next, we'll move on to comparing center. In order to compare center, we just need to look for the median of each data set. I notice that Bookstore A has a larger median because its median is further to the right than Bookstore B's median. So all I need to say is that Bookstore A has the larger center. And if we're thinking about what this means, it means that the typical price of a book at Bookstore A is a little bit higher than the typical price of a book at Bookstore B. Finally, we'll compare the spread of the two data sets. I notice that the data set for Bookstore A is wider than the data set for Bookstore B. It starts at a lower number and ends at a higher number. So altogether, it's obviously got a larger range than Bookstore A, meaning it has greater spread. So again, interpreting what this means, it means that Bookstore A has a little bit wider range of prices, a little less consistent in how much it charges for a book. And with these three comparisons, we've really summarized the similarities and differences between the two data sets for the two different bookstores. Now let's finish things off with a couple of true-false questions that make us think a little bit deeper. The first one says that for Bookstore B, there must be a book that costs $70. So let's focus on the Bookstore B data set. We notice that 70 is the lowest value of the Bookstore B data set. And we know that the lowest value of a data set is always obviously included within that data set. So 70 would have to be one of the data values within Bookstore B. So this is true. Had they said a number like 82, I wouldn't know necessarily whether or not 82 is a data value. Because all I know is that there's 25% of the data values within this range, but I don't necessarily know what the individual data values are. The only two data values for a data set that I know for sure, based on a box plot, are the lowest value and the greatest value. Next, we're told for Bookstore A, the number of books that are $65 to $75 is equal to the number of books that are $105 to $130. So let's focus our attention on Bookstore A, and let's look at this range, $65 to $75. Remember, this covers 1/4 of the data, so this is 25% of the data values right here. 105 to 130 ranges from here to here, which also covers 25% of the data values. So even though this range is wider than the other whisker, they both contain that 25% of the data values, meaning the same amount of data is in each range. So this is also true. This is just a tricky application of that 25% rule, where you have to realize that it doesn't matter how long the range is, it matters how much of the data it contains, and all of those quarters of the 5-number summary each include the same amount of data. To summarize, the 5-number summary is a list of 5 numbers that divides the data evenly into 4 quarters, each one of these quarters then representing approximately 25% of the data. A box plot gives us a visual representation of this idea. If you came away with anything else, write that down now. Otherwise, we'll see you in the next lesson.